ETL pipelines are a crucial part of data engineering. Now, today I'm going to walk you through how you can build your very own ETL pipeline to process data. But before we jump into that, let's have a look at what ETL really means. ETL is short for extract, transform, and load, which are three different parts of an ETL pipeline. Now, that extract stage, that is simply getting the data, whether that is uploading a file or downloading it from a source. All of these things can be seen as extracting the data. After that, you might want to transform it, such as removing some sensitive data, adding a new column, maybe manipulating data that's already there. You might do something like that with something like Python. And then afterwards, you would then load it into a destination. That could be as simple as a database, but it could also be something like a data warehouse like BigQuery, where you can then go and do some analysis on top of it later. Now, ETL is so important when it comes to taking effectively raw, messy data and getting it tidied up ready so you can start doing some data analysis on it later on, which is why many companies around the world use ETL pipelines to process data they're generating every day to get it into a useful format. Now, we're going to build an ETL pipeline that's going to use some data from... Now, we're going to make an ETL pipeline that's going to take both some product data as well as orders about those products. We're going to combine them to figure out how many of these products have actually been sold and how much money they've made. Once we figure that out using Python, we'll put the end destination into a database so we can easily visualize that. Now, to do that, we're going to use a tool called Kestra that's going to make taking those different parts of the process and help us stick them together. So we'll be able to download the data from Hugging Face, we'll be able to transform it using Python, and then we'll be able to load it into our Postgres database. To get started, we're going to need to set up some Docker containers that will run Kestra, but also the Postgres database that we're going to use a little bit later for storing our data in. So here I've got a Docker Compose file that's got 4 different containers. We've got a container here for the Kestra database, which is using the default template from GitHub. I'll have a link in the description. We've also got the Kestra configuration for the Kestra server. Again, this is from the template from GitHub, but as you can see, this is going to start Kestra up for us. Further down here, I've got my Postgres database for the ETL pipeline. This is just a very standard Postgres configuration that is going to allow us to be able to connect using Kestra. And because we've done it in a Docker Compose file, they should all be able to talk to each other. And then lastly, we've got pgAdmin here at the bottom, which will allow us to be able to have a look inside of that Postgres database and just make sure we're getting the results that we expect. Now, all we got to do now is just type Docker Compose up, and this is now going to spin up all 4 of those containers so that they work together. And then we can go over to our browser and head over to localhost 8080 to be able to see Kestra. Now that we're inside of Kestra, I'm going to create my first workflow. And this is going to give us a little tutorial. I'm going to skip over that for now. But this will then give us the editor that we'll use to be able to define our ETL pipeline. Now, if I open the topology view, we'll be able to see the different tasks visualized and where they sort of relate to each other. At the moment, we've just got the one log task, but we'll change this in a second to match a little bit more what we're trying to achieve. I've just named it ETL Pipeline 1 and I've saved it, so now we can come back to this. But let's first have a look at the data that we're going to take from its raw format and convert. We're going to start off by taking this data, which has a number of columns. Most notably, it's got order ID, customer name, customer email, product ID, price, quantity, and total. So we can figure out which products were sold with which order. We can also see the customer name. Now, at the moment, this is split so that the customer's first name and last name is all in one column. Now, we're going to have a look at how we can split that into 2 separate columns and create a new column that we can then put in our Postgres database. This could be useful if you want to be able to sort by last name, whereas at the moment you only be able to sort by first name. Afterwards, we can then look at expanding this so that we can get the product IDs and figure out how many products were sold for over these 100 different orders. Now, to start with, we're going to change this first task and we're going to call it extract, as this is the E of the ETL pipeline. I'm then going to go to type, and here I'm going to type in download. So we'll be able to expand that and we can scroll down till we see HTTP download. So as you can see, this is going to let us download a file. I'm then going to put the URI property in, which we can see here is a required property. And I'm going to take the URL of this data set and paste it in here. So now when I press save and go to the topology view, we'll see that we now have that task ready to go. And if I also execute this workflow, we'll see that when we execute the workflow, it was able to download that file. And if we go to outputs, we can actually view that file as well. So we can see Kestra now has access to that data. So that's the E of ETL sorted. Now let's have a look at transforming that data using Python. Now that we've got the extract task ready to go, and we can see that in the topology view here, we can now do the next stage, which is the transformation, which we're going to use Python for. So what we can do is create a new task. I'm going to call this one transform, as that's what it is. And then I'm going to put the type, and I'm going to type in Python. Now, there are a few different Python tasks inside of Kestra. We're going to use the Python script task, which is going to allow us to write our Python code directly inside of the workflow rather than using a dedicated file. This will make it easy, one, because we can use expressions, which allows us to be able to take data from other tasks, such as that extract task, and pass it into the transform task. But it also allows us to be able to just keep it all in one file, especially where we're not going to be doing tons of transformations. But if you're doing something a little bit more complex, then a dedicated file might be a better choice. Now, we can have a look at the documentation for this task to understand what's required and what we need. Now, I know that I'm going to use pandas for being able to do the transformation. So let's have a look at how we can add that dependency. Now, there is a new property in the latest version of Kestra called dependencies. So I'm going to type that in like so. And I'm going to just list pandas as an option. So now pandas will be installed by default when we try and run this task. Next, we want to be able to take that data from the extract task and pass it into this task. So using the input files property here, I can now specify a file. I'm going to call it CSV. I'm going to call it data.csv. And then I can use an expression here where I can do outputs and then an ID of the task, so in this case, the extract task, and then I can see the 4 different things it will let me access. Now, I know that it's going to be .uri, but if we were to go back to the outputs tab, which we can do in a second, we'll see that that was the one that we previewed. So we know that's the data, and that now means that when we run our Python code, this file called data.csv will automatically be accessible inside of the Python code. So we can just open the file like we would on our local machine, data.csv, and we can get working with pandas to transform the data. The input file is great and all, but we also need to be able to produce a final CSV file with the transformed data that we can then put into our database. So I'm then going to also add the output files property like so. And then here, I'm just going to list the file as orders.csv. So now any CSV file called orders.csv that is saved will automatically then be produced as an output file so we can access it in later tasks. This is useful if you produce a lot of files, but you want to make sure that only certain ones are then accessible to other tasks. Then the last property to add is the script property. Now, as you have guessed, this is the property that we're going to use for being able to actually write our code. And we can see that script is a required one. And if we go to the examples, and I'll just make that a little bit wider, we can see that this is how we're going to write our Python code. So let's start writing that, and we'll add that in now. So here's some code that I added in earlier. Now, I mentioned earlier that the goal that we're trying to achieve here is to take the customer name property and split it into 2 separate columns. So what we're doing first is we're going to import pandas. Then we're going to read in our CSV file called data.csv. Then we're going to use our data frame here to be able to create 2 new columns from the original one. And we're saying that we want it to split using spaces. Afterwards, we'll then drop that customer name column because we don't want it anymore. And then we'll specify that we want the columns in this order, where first name and last name are effectively replacing that customer name one. Otherwise, if we were adding new columns, it would just add it to the end, and we don't want that. Then we're going to save it to CSV called orders.csv, and we don't want it to have an index because it already sort of has that. As we've seen, it's already got order ID, which is effectively our index. So we don't need it to add another one on top. So if I execute this workflow now, what we'll see is once it's extracted the data and then transformed it, we can go over to that outputs tab and have a little look at the output file that is produced via the Python code. Now, it is worth noting that this Python code is going to be run inside of its own isolated container. So this means that you won't run into any issues issues with dependencies clashing with one another, and it just keeps everything isolated. So it means it can take a little bit longer to run, where it spins up a container, installs all of our stuff, runs the code, and then kills the container. But you have got the option to run it as a sub-process if you would prefer. You just then lose the benefits of a container. We can have a look at outputs here. So we can see the transform task was successful. It did produce an output file, which we can see here. And if I preview that, we can see that first name and last name have now been successfully added. So here we can see that these two names are now separated by columns. However, it's not foolproof because what we've done here has not really accounted for every edge case. We can see here that some people have doctor in their name. So it's put doctor as one name and then the rest of the name as the last name, which we know is not what we want to do here. Now we could modify our Python code to then be able to put Dr. Dawn, for example, in one bit and then YMD as the last name, but we're going to ignore that for now so we can focus on doing the last step of ETL, the load step, and then we'll look at our slightly more complex scenario that won't rely on this situation. So like I mentioned earlier, we've actually already got a Postgres container running for that load bit, because what we want to do is effectively take that data and then put it into a database where we can just keep adding orders in the future. So it's all in one place and we're not relying on a CSV file. So after our Python code, and we can again look at that topology view to see we've got extract and transform, we're now going to need some SQL tasks. Now we're going to need a few here because there's two things we need to do. The first one is creating our table in the database that we can then add the data to, because right now database is empty. There's no tables for us to add the data to. And then the second is then copying in that CSV file and matching it to the headers. So I'm just going to create a new task here called create table. And this is going to use a Postgres query task. So we're going to make one single query here, which we can do by typing in SQL like so. And then I can just put in my query here. So this is looking good so far, but it's still unhappy because we're missing a few properties. Specifically, we haven't got the username or the password properties. So let's make sure, and also the URL. It doesn't know where our database is. So we better specify that by adding URL in here and then putting it in. So we're making good progress here. I've added the URL, which is using the JDBC connector, then Postgres, and then after that, I can specify the domain. So in this case, because I'm running it in Docker, I can simply just put the name of our container, which here is specified as pg_etl. And then I can put the port number, which is 5432, and then the name of the database itself, which I have just called ETL. So with that in mind, this URL is correct. The username is also correct. I just need to add the password. Now, I could just hard code it here, but that's not very good practice. We don't want to put our passwords in plain text available. If we version control this, that's just there and open. So what I'm going to do now is instead go to the key value store here, and I'm going to create a new key value pair called pgpassword. And then I'm going to paste it in. I'm just going to see what it is, which is this. It's specified in my Docker Compose. And then when I press save, that will now be accessible. So if I go back to flows, go to our ETL pipeline, I can now see this is accessible, and I can access it using an expression like we did earlier, where I can put pg_password. And now what I should see is when I press execute, this is going to be able to create a table for us using the SQL query that I provided. So as we can see, this was all successful from the Gantt view. And if I click into that, the SQL task, I can see that it has created that table. Now, the only way to check that is by going to, you guessed it, pgAdmin, which is running on port 8082. So if we go to a local host and then go to port 8082, we'll see that it's all ready to go here. Now we need the username and password, which again are specified in the Docker Compose. So it's admin@admin.com and the password is root. If I press login now, we'll see that we are now in, and I can add a new server. Now I'm just going to call this pgETL, and then under connection, we need to put pgETL. It's running under 5432, and the database is called ETL, if I'm not mistaken. That's correct. And then we just need the username and password. So the username is Kestra, and the password here is Kestra with some funny characters in. So if I press save now, the database has in fact loaded. We can see ETL has come up. And now if I scroll down, we can see that under schemas, and then under tables, we can see that orders, the table that we created, and we can just double check that. I called my table orders. I told it to have these number of columns with these different data types. And hopefully if I just view that table by right clicking, I should be able to see it's got all of those columns as expected. All we've got to do now is just load the CSV file in, and we've created our very first ETL pipeline. So let's add one last task here, which is going to be another Postgres task. So I'm just going to call this task load to DB. Again, the type is going to be a Postgres one, and we're going to use the copy in task. So this is going to allow us to take the data that we produced from Python. So if I put output transform and then output files, and we know that the file we produced is called orders.csv, this is getting much closer to being able to add that data in. We've just got to specify where we're putting it. So specify the database information itself. So we'll just copy and paste that from the task above. So we need to specify that there is a header in the CSV file. This will mean that it will ignore that first row rather than trying to add that in because the table's already got headers. Then we need to specify which table we're putting it in, which is the orders table. And then lastly is that delimiter. So the CSV is delimitated using a comma. So in between each of the columns, the commas. So it just knows how to interpret the CSV file. So now if I press execute, we'll see that it's going to now extract the data. It's going to transform it with Python. It's going to not create the table because it already exists. But if it didn't exist, it would create it. And then after that, it's then going to load that CSV file that Python produced here into that database. So as we can see here, it's now run. If I go back to pgAdmin and I rerun this query at the top here, we can see that now, if I just make that smaller, we can see that the data is all available now. So we can see all of that data that we saw. The first name and last name now have their own separate columns. So that was the transformation that we produced. And now it's accessible in a database. So if we wanted to do more with this, we could. Now, while that was a cool example of ETL, it doesn't really show the power of being able to transform this data and load it into a new source. So I want to take this example and expand it even further. Now, this is where things get a little bit interesting. So previously, we had a CSV file that looked a bit like this. Contains a bunch of order information, including things like order ID. But the interesting thing is it has another ID property called product ID. That's where this second CSV file comes in handy. So this second CSV file is much shorter, but it's a summary of all those products. So now we can take orders and understand what the product is, so we can give it a name. And I think it would be interesting to understand how many products have been bought and how much money that has made in total. So what we're going to do is take both of these CSV files, use pandas to be able to sort of combine them to create a one merged CSV file, and then we can load that final response into a new table. So the first step is two separate extractions. We're going to extract both of these data sets as CSV files, and then we're going to then pass those into a new Python task. So the Python task, very similar to the last one, but now we've got two different input files. And now what we're going to do is we're going to read in that orders.csv like we did before. We're then going to group it by the product ID and the quantity so we can get a sum. We're going to sort the values. And then after that, we can start looking at the products. Then we can combine what we want from the product CSV, which is the product ID, so we can match it to the orders, the product name, so we can give it a bit more of a description, and the category, as well as the brand. And then after that, we can then combine it all together so we can get a new CSV file that has these columns: product ID, product name, product category, the brand, but then also the total quantity sold and the total revenue. And we're calculating all of that above over here. Once we've done that, we can merge it all together and then save that as a CSV file. So if I now execute this, what we'll get is a new workflow. Let's just see it running in action. And then once it's transformed, we'll be able to have a look at those CSV files to see our new end result. So here I can go to transform and I can see my product summary has been generated, and I can see for the 20 different products, how many were bought and how much money that was, because each product has a total price. Now, the thing that's a little bit odd about this data set is the price for the product it varies. So some products were like our product ID 20 was sold at this price. They only sold one, so the total was this. But somewhere else, product 20 might be a bit different. So again, a few things that are a little bit unclear, but we're going to work with what we have. Potentially, this is something like, something that could be negotiated. The price isn't necessarily fixed. So it's important to be able to take those prices at each sale, at each order, to make sure that we're getting the correct number rather than assuming all of them are sold at the same price. At the end of the day, we're just trying to work out how much was made in total. Now in our next task, we're going to create that table. Now if the table doesn't exist, it will create it, but if it does, it will just skip over. And we're going to make sure we're using those same columns that we just created for the CSV file up here in Python so that it matches. And we've got the same data types too, so it should have no issues. Now if the table does exist, it will then truncate the table to make sure there's no data inside of it so we don't get duplicates. So it will run on new data every time we run the workflow. And then at the end, we're going to do the same thing we did in the last example, where we're going to use an expression here to be able to copy in the CSV file produced by Python and then put it into that database. So I think it's time to execute this workflow now, see it run in action, and then we can have a look at pgAdmin to understand, is the data as we expected? So as we can see here, we've extracted both of those products. If I go to outputs, I can actually go and view them. So I can view both of them and see that it's got the correct thing. I can see that the Python has in fact produced another CSV file with our new transformed data. And now we can see that it has in fact loaded it into the database. So now if I go onto pgAdmin and refresh, we'll see that there are now two tables. And if I go and view all the rows in that next table, we can now see that it has successfully got all 20 products. It's got the names for each product, the category and the brand. We can see how many were sold, and we can specifically see how much revenue each product made. Obviously, all of this data is dummy data, so it doesn't necessarily make a ton of sense. But imagine a scenario where you're a company that sells products and you would want to be able to figure out what's your best selling product. This is a fantastic way of being able to take just raw customer orders and information about those products and turn it into something useful, which you can now do data analysis on, which just emphasizes how important ETL pipelines are in a business setting. So just to revisit, we've built two workflows here. The first workflow that we built, it looked a little bit like this, where we were extracting some data from Hugging Face as the place we were getting it from, but it could have been anywhere. We were then going to transform it using Python to be able to add two columns and to replace one. Then we're going to create a table in our Postgres database so we can then load the final data into the database for us to view and use in the future. But then we took that a step further with our second example, where in this example, we wanted to be able to take two CSV files, which both had relevant data, be able to combine them and then do some calculations on top of that to figure out which of the products were the most successful in all the orders that we had. Once we got that final response into the CSV file, we could then load that into the database too, which we've then seen here using pgAdmin. And that was all thanks to being able to use a Docker Compose file here, which combined Kestra, pgAdmin, as well as that Postgres database, so they could all talk together on the same network. So hopefully that gives you a good idea of how to build your very first ETL pipeline using Python, Postgres, and Kestra. I'd love to hear what you think in the comments below, and if there's any examples you'd love to see in the future in the data engineering space.